test, you're going to have to, you'll like be reading questions, and you're going to have to identify where it falls into what we're doing, okay? Because this is all like probability, combinations, things like that, and so you're going to have to read it and say, oh, is it this situation, this situation, this situation, right? So this is a way of breaking down how to determine one of 4 possible ways, okay? All right, so last class, we had 2 things that we talked about. We talked about whether an event was independent, okay, or whether an event was dependent, okay? And independent was pretty much the first choice, did not affect the second choice, okay? So an example that we used was, like, let's say we're doing a passcode, right? And you have a 4-digit passcode, okay? And I have 10 options, 0 through 9 here, 0 through 9 here, 0 through 9, and it doesn't matter what I pick for the first one. Let's say I pick number 3. That does not affect what my second choice will be, right? So let's say I pick 4. And then I could pick 3 again, and I could pick 1. So each one of these is independent of each other. They don't affect each other. So I have 10 options for this choice, I have 10 options for that choice, I have 10 options for that choice, and I have 10 options for that choice. Okay? So we called this the fun counting principle, FCP, in which we just say all you do is multiply each amount of options that you have for each element to get your answer. Right? That was independent. Okay? Then we move on to this, what was called dependent. And dependent meant the first choice did affect, okay, your second choice. Okay? And the example I'm going to use on this one is, let's say I have 5 people. I have 1, 2, 3, 4, 5 people, and we have a table setting, and we have 5 places in which people will sit. Okay? So we have 5 people trying to sit around a table of 5. Okay? If I put person number 1 here, well then I can't put person number 1 here, can I? So now I'll put person number, let's say 2. So my first choice is affecting my second choice, right? Does that make sense? So here I have as many choices as outcomes. Okay, I have 5 people, and I have 5 people around a place setting. Okay, so there's as many. And so what happened here is we call this a factorial. And we just said it was 5.4.3.2.1, and we wrote this as 5 factorial. Okay, so basically it decreases one at a time. Okay, so we're going to call this dependent option A. Okay, so we're going to talk about 3 different dependent options. This was our first one, and this was 12.1, and this is 12.1. Okay, so the very first thing when you get a problem is you're going to have to read it, and you have to decide, is it independent or dependent? That's going to have to be number 1. So step number 1, is it independent or dependent? If it's independent, you go straight here. If it's dependent, you're going to have 3 options you need to figure out from. Okay, we just learned the first one. Okay, then we have the second one. Okay, we're going to call this dependent B, or 2, whichever one you want. Okay, and this is, again, where the first choice is affected by the second choice. Where I have, let's say, 1, 2, 3, 4, 5 people, and I have a place setting, but now I only have 3 spots. Okay? So now my choices, okay, are less than my options to pick from. Okay, so here I have 5 people, but I only have 3 spots to put them in. Okay? And so we're going to have this twice. We're going to have the same thing. C is going to be the same thing, where you're going to have 5 people, and you have a 3-place pace setting. Okay, so it's the same concept. There's just going to be one difference. Okay? So again, you have my choices. You'll see. Okay, so my choices are less than my options to pick from. So again, I have 5 people, but I only have 3 spots. Okay? The difference between these two is going to mean, this is going to mean order matters, and in this situation, order does not matter. And what do I mean by that? Well, in this one, let's say I put number 1 here, number 2 here, and number 3 here. Okay? This is an order where 1 goes here, 2 goes here, 3 goes here. It is a different solution set if I put 2 here, 1 here, and 3 here. That's a different solution set. So I could have 1, 2, 3. I could have 2, 1, 3. I could have 3, 1, 2. I could have 3, 2, 1, just with those 3 individuals. And how I arrange them is a different solution. Okay? So I have the same numbers, or the same picks, but I put them in different order. And when I put them in different order, notice how I now have 4 solutions with just those 3 numbers. Right? Here, order matters. This is one solution, that's another solution, that's another solution, that's another solution. Okay? On the bottom here, order does not matter. Okay? So basically what that means is, if I pick 1, 2, and 3, if I put 2, 3, and 1, it doesn't matter. It's the same 3 people. So in this case, if I do 1, 2, 3, 2, 1, 3, 3, 1, 2, 3, 2, 1, this all one solution because they're all the same 3 people. And where you might see the difference is as follows. Let's say whoever sits here gets $20, whoever gets here gets $10, and whoever gets here gets $5. Well, if you mix them up, then different people get the different values, right? So it's not the same outcome. Here, if everyone gets $5 regardless where they sit, it's the same solution. It doesn't matter. Okay? We will not tell you order matters. We'll show you ways in how you indicate that. Okay? So we're going to walk through today looking at how, like, when you would see something like this and when you would pick from the other. Okay? We call this situation a permutation. Okay? We call this situation a combination. Okay? And so today what we're going to look at is how to identify if order does matter or if order does not matter, and then how to do it. Okay? Both of these can be put into your calculator. So once you identify what it is, it's easy to just punch into your calculator. Okay? But do you guys see the difference between how, once you realize it's dependent, how you have 3 possible options here? You have it where all your choices are being used, which is then factorial. You have it where not as many choices are being used, but order does matter, and you have it where not all is being used and order does not matter. Those are the 3 things we need to identify when reading these problems. Okay? All right. So, with that said, we're going to move on. Let's look at our sheet from last time. Yeah?
Did the bottom one say combination?
Yeah, combination. Okay. All right, so last time, you guys, we were working with, this is factorial. Again, this is going to be dependent And then that's the A one that we just learned, right? This is dependent. And this is with our factorial where we had in our calculators. So let's go ahead and get our calculators out to remind ourselves how to do this. Okay? Okay? So when we see the 10 exclamation mark, it is called 10 factorial. And again, punching it into your calculator. Each calculator is different, so go ahead and see if you guys can remember how to do it. You should get a really large number of like 3,628,800. Yep. Yes. You should get like 3,628,800. Okay. All right. So now when you have a 5 factorial, 3 factorial, so that's kind of like the same thing as 5 factorial multiplied by 3 factorial. Okay. So you would then go 5 factorial, and then you would multiply by that by 3 factorial, and you should get 720. Okay, if you have parentheses, you could do parenthesis 5 factorial, and then do a parenthesis again, 3 factorial. Oops, that didn't work for some reason. All right, did everyone get 720? Okay. All right, then when you have this 5 times 4 factorial, you want to, it's not 20 factorial, guys, you want to do 4 factorial first, and then times it by 5, and you get 120. And notice how that's different than 20 factorial. Okay, so you want to make sure that you kind of follow the orders of operation what's inside the parentheses first, so you do the 4 factorial first, and then you multiply it to the 5. Okay? And then when you do the division here, if you put this into your calculator, you want to make sure that you do the 15 factorial. When you divide, make sure you do the 10 factorial and the 5 factorial first, and you divide 15 factorial by that. Okay? Because otherwise, some calculators will do the 15 factorial divided by 10 factorial and then take that answer and then multiply by 5 factorial. So you want to make sure that you do that correctly.
So because it's division,
when you guys calculate this, you should get 3,003 as your answer. Okay? So is there anyone on their calculator who is not able to get those numbers? I was just mentioning to you guys on this situation here, we had permutations, right? Where we had a whole item to choose from, and we were only selecting so much from it, right? Okay, so we call these permutations. So on permutations, you guys, it breaks down as follows. A permutation, again, is where you have, it's a dependent event, okay, and it's where you are selecting less than your options, okay? And so we have 2 variables that we're going to talk about. We have this n and this r. N is going to equal the amount of objects to choose from. Okay, and then you have r, which is how many you're selecting. Okay, so if I look at my example I gave you guys, okay, if I gave your example here, my n is what? What is my n on this example? My n is my total number of objects, 5. So my n is 5 in this example. How many am I selecting? 3. Okay? Does that make sense? So they have this wonderful equation you can use. There's two of them ways you're going to see it. You're going to see it P in parentheses NR, or you're going to see it as NPR. Okay. So how this gets written as in our situation of the chairs, okay, is it would be 5P3, or you would see it as P5, 3. Okay. So those are ways that you can write it. And when you write it this way, what our calculators will allow us to do is to input it. So you write it this way so you know how to input into your calculator. Okay? So you kind of good on the NR thing? The P stands for permutation. So here, if order does matter, then it's telling you that you want to use a permutation. Okay? So how do I do this on my calculator? Well, alright, here they gave us some examples. They gave us 8, I don't know if you can see it really well, P1. So each calculator is different, just like with your factorial. On most calculators, you have a PRB number, or PRB button, or you have math. If you went on your graphing calculator to math, you're going to hit math. Here, can I borrow yours real quick? Okay. So on these calculators here, you hit math. Okay. You go over to the probability, and then instead of going down to the exclamation part, you're going to go down to where it says NPRB. Okay, you guys see that okay? It's kind of hard to see here. And then you would hit enter. Before you do that, so I'd do 5, I would do math, I would scroll over, and I would hit NPR, and then I hit 3. So you hit your first number, you hit the N, you hit the PRB, and then you hit 3 and hit enter, and that's what it will tell you, the number. Okay, so on that type of calculator. Okay? On I don't know if you see it, there is a second NPR here. So I'm going to hit 5, I hit second NPR, and I hit equals, and I hit 3. Oh, it didn't work. Okay, 5, second NPR, 3 equals, and then it should say 60. Okay? Let's try the worksheet one. So we have 8, 1. So I'm going to do 8. I'm going to find the NPR number. I'll do 1, and I'll hit enter, and you should get 8. You should get 8 as your answer. Okay? So this should equal 8. Okay? And how does that work? Why does it work that way? Well, there's actually a formula for this. You don't have to know it, but I'm going to show it to you what it is. So, for permutations, you guys, the actual formula for it is going to be the N all over the N minus R factorial. Okay? So that's how that works. Okay? And so then if you would do that, then that's how it would work. Okay? All right, questions? All right, so let's try 8-3. Let's try 8-3. So we're going to have 8. We're going to do second PRB, and then we do 3, and then you should get 336. Okay, so you get 336. So that would be 336. All right, is everyone good on getting on the calculator? All right, so now let's look at a situation in which it's permutation. Look at actual problems, like the actual, when would I see this? So let's look at the first one. We have 8 people entered into a pie contest. How many ways can blue, red, and green ribbons be awarded? Okay, is it the same if I pick 3 people and I give person A a blue, give person B a green, and give person C a red? Is it the same if I then give person A the red? Is it the same combination? Like, let's say you guys are in a sport. You're in a tournament, right? And you're in the top 3. Is it different if you get first place versus third place? Yeah, right? What place do you want? First. Are you as happy as you get second or third? Usually not, right? So order matters, right? You had the same three people in first, second, or third, but you care if you get first, second, or third, right? So that is a way in which order matters. That is a permutation type situation, okay? So we have three different ribbons we're giving out. So what is our N? So we know it's a permutation because order matters. Okay? So what is my N? I need an N, I need an R. My N is the total population. What's my total population? 8. How many am I giving out? 3. Okay? So this is my total population. And then this is what I'm picking from. Picking 3. So I could rewrite this as 8P3. Or I could do it as P, 8, 3. And then it still goes into your calculator this way. Okay? So at that point I would just plug in what we just did up here. And so you should get 336 possible ways that those 8 people can get selected and have 3 ribbons. Okay? Alright. We have your coach has 12 team jerseys numbered 1 through 12. He plans to give one jersey to of the 12 members of the basketball team. How many ways can the jerseys be assigned? Alright, so let me just stop you for a minute. We have, is it independent or dependent? Number 1. You always want to take each one of these problems. Is it independent or dependent? It is dependent. So then you have to look to which one of these does it fall into. Alright? Do I have as many choices as outcomes in this situation? I do. I have 12 jerseys and I have 12 people. So I really could just do what? I could just do my 12 factorial. Right? Because the first person has 12 options, the second person would have 11, etc., etc. Right? I could. Now, I also could do a permutation. Let's say you're like, well, I'm not sure. So let's try a permutation. Well, if I do a permutation, what's my N value? 12. What's my R value? 12. Okay? So permutation and factorials work the same if it's the same situation. Okay? So at this point it'd be 12P12. Okay, well what does that equal? Let's see. Let's go 12P12, and you're going to get like a really large number. You're going to get 479001600. Did I do that right? So you get 479 million. Alright, well if I do 12 factorial, do I get the same thing? So I'm going to do 12 factorial, and I get the same thing. So you can see how, in this situation, if it's factorial, permutations will get you the same answer. Okay? What's that? Okay, so questions on that? Alright, so now we have what we call permutations with repetition. Okay? Meaning order matters, but we have duplicates. Okay? So here's an example. How many different ways can the letters of banana be arranged? Okay, well the first thing we need to know is N. Okay? How many letters do we have? 6. We have 6 letters. Okay? Now they can be arranged multiple ways. However, we have multiple N's and multiple A's. So we don't know what A is what A and what N is what N. So what we do then is we just break down each letter. So how many B's do I have? How many A's do I have? And how many N's do I have? Okay, so these kind of act like my R's. So I really can rewrite this as 6 factorial, okay, and then I'm going to divide it by all my letters factorial. So 1 factorial is just 1, so I won't write that. But 3 factorial and 2 factorial. Okay? So I take my repetition and I make those factorials on the bottom. And then you just work this out through a calculator. Okay? So if I do that, if I work it out through a calculator, you should get 60. You should get 60 different ways that you can rearrange those letters. Okay? So try Mississippi. Okay? You have, how many different ways can Mississippi be arranged? So try to do that with what I just showed you. Okay? Alright, so in this situation, you guys, does your first choice affect your second choice? If you get this problem on a test, you're going to say, okay, how many can these be arranged? So you have to ask yourself, is it independent or dependent? So if I pick P to be my first letter, does it affect the choice I could have for my second letter? Yes, you can't use that same P twice, right? So it's a dependent event. Okay, so number one, you have to decide if it's independent or dependent. So when you see this, you'll say, oh, it's dependent. So now I have to decide which way do I use it. Well, when you're arranging things, I have multiple S's and multiple P's. So it's kind of like one S is the same as the other S, and you don't know. Okay, so we're going to go into where we have 11 factorial because we have 11 letters. Okay, but we have multiple S's. We have 4 S's, we have 4 I's, and we have 2 P's. So the system can't decide between one S and the other S. It's all the same to them. So what you do then is you put the 11 factorial over the 4 factorial, all over the repetition. Okay? You could put it over the M as 1 factorial, but then 1 factorial is just 1. So you could do that if you want. But this just takes out the repetition of all those different letters. Okay? And then when you put that into your calculator, you should get 34,650 ways that you can arrange those letters. Okay? Yeah, I mean, you can arrange the letters, and then have it still say the same word. But you wouldn't know because it's like the same letter. Alright, so this is permutations, you guys. Alright, flip. We'll talk about combination. Okay, so in combination, you guys, we talked about how order does not matter. Order does not matter. Okay? That's the difference. In permutation, order mattered. You guys care if you're first, second, or third, don't you? Okay? If the top 3 teams get first place, does it matter in which order you're called? If the top 3 teams all get first place, does it matter in which order you're called? No. So that's a combination. Okay? So how do we do that? On our calculators. Okay, so combination is where you have you're picking less than what you have out there, but order does not matter. Okay? So you're picking less than your choices, and order does not matter. We can plug this into our calculator just like you can. You're going to see this as CNR or NCR. Okay, so the same thing, but instead of it being a P, it's a C. C stands for combination, P stands for permutation. So on your calculator, you can evaluate the same way. Okay, so if I have 8C5, okay, that also can be written as C85, same thing. Okay, in my calculator, then I'll do 8. Instead of doing the NPR, I'm going to do the NCR. So the exact same way you guys got to the permutation, you should be able to get to the combination. It's just one choice below it or to the left or to the right of it. So I'll do 8, I do NCR, I hit enter. Oops, I got to do 8, NCR, and then I do 3, and you should get 56. Okay? So on your calculator, you're able to get 56. Okay? So now on the calculator, try 4C3. So I'll do 4C3, and I should get 4. Okay? Is everyone able to get that? Okay, so try it on your calculator and see if you can get it. If you have the exact same N and the exact same R, and you plug it in as permutation versus combination, you will get less combinations than you will permutations. And why? Because order matters in permutation, so the same 3 teams can be multiple answers versus in combination, they're all just one group. Okay? So so you'll have less combinations. Does that make sense? Okay. All right, so let's look at how we would use this. Okay, you have 5 cousins. At a family reunion, decide 3 of them will go pick up pizzas, because no one wants to stay at a family reunion. They want to get out of Dodge, right? So they fight over the 3 who should go. So you pick the 3 that are going to go. Does it matter once you pick the 3, does it matter who gets in the car first? No. Just how many ways can you choose the 3 people to go? So you're going to either choose cousin Vinny, cousin George, cousin Mary, or cousin Mary, cousin George, cousin Vinny. Regardless, you're picking the same 3 people, right? So order does not matter. So it is dependent, okay, because the number one thing we need to decide if it's independent or dependent. And here, order does not matter. Now, if you said the first person gets shotgun, the second person gets the middle seat, and the third person gets the trunk, order would matter, and now you would have a permutation. Because then you would care in what order you were picked, right? Okay, so you see the difference between...
So order is P and then the other...
Yes, order is P, and combination is that there's no order.
So something that matters, like that's dependent. So no, they're all dependent, but...
They're all dependent, but order is going to be permutation. Okay? If order does not matter, then you're just selecting a group and it's just called a combination. Okay? The easiest way I think of it is order is close to P, which is permutation, so when order matters, I use the P one. Combination is just like, doesn't matter. I don't know. So at this point, I would say, what is my N value? Okay? What is my N value? 5. And then what is my R value? 3. So you're going to do 5C3 in your calculator. Okay, so you do 5. And you should get 10. There should be 10 ways in which you can pick your cousins. Okay? There's also the mathematical way, if you want to know it. It's where it's the n factorial over n factorial, or n minus r, not n factorial. So it would be n minus r factorial, which is the permutation, but then you minus r, or then you multiply by r factorial. So this is like the mathematical way, but your calculator does it for you. Okay? All right. Questions on that? All right. How many of you guys are familiar with the deck cards? Is anyone familiar with deck cards?
I've never seen a deck card.
You have, because you played it in class. Okay. So we have it where we have combination, where we can do multiple events, where you're going to combine like combination and then what we did before. So let's walk through this example. Let's say you have 52 cards. Okay? In 52 cards, you have a total of 4 suits. Okay? You have diamonds, you have hearts, you have spades, and you have clubs. Right? There are 13 cards in each suit. Right? Ace through king. Okay? So I have ace through king of diamonds, ace through king of hearts, ace through king of spades, ace through king of clubs. Right? You're all good with that? Okay. Alright, so then the question is, I have 6 cards that are drawn from a standard deck. Okay? How many hands consist of 2 hearts and 4 spades? So, if I look at hearts, if I look at diamonds, clubs, hearts, and spades. Alright, if I pick 6 cards, how many diamonds will I pick? I'm looking for 2 hearts and 4 spades. So how many diamonds would that be? None. So out of my 13, how many diamonds am I going to pick? 0. Okay, so my N is going to be 13, but my R is going to be 0. Right? So I'm picking nothing out of them. If I have clubs, how many clubs do I have? 13, so my N is 13. How many am I picking of those? 0. Then I get to hearts. How many hearts do I have? I have 13 total. How many of those can I pick in this situation? What's my R going to be? 2. Because I want 2 hearts. And now it wants 4 spades. So, my N here is 13. What is my R? 4. Okay? Does it matter in which order I pick my heart versus my spade? So therefore I'm doing a combination, right? Okay. So now all I got to do is I have 6 cards I'm picking from, okay? So all I got to do is multiply these together. These are my 6. 1, 2, 3, 4, 5, 6, right? So I'm going to take and do combinations on each one of these. I'm going to do 13, 0. I multiply by a 13 combination 0. Okay, that's my diamond. That's my club. I'm going to multiply by 13 what? 2. That's going to be my heart. And then I multiply by what? 13 combination 4, and that's going to be my spade. So here I'm combining the combinations to get my total answer of how many hands will consist of that. Okay? So you plug that into your calculator. Well, this right here is just going to be 1. So these cancel out. So I just have 13C2 and 13C4, and I multiply them together. Okay? So go ahead and try and do that in your calculator and see what answer you get. So when you plug it into your calculator, you're going to get 13C2, and that's going to be 78. And then you're going to multiply by 13C4, and you get 715. And when you multiply those together, you should get 55,770 hands that consists of 2 hearts and 4 spades. Okay? Alright, let's see then now if we can decide if they're permutations, combinations, or when you say fun principal counting, we're talking about if it's independent or if it's the factorial. Okay, so let's read these. 15 students asked to visit a college admission counselor. Each scheduled visit includes 1 student. How many ways can 10 time slots be assigned? So do my N and my R equal each other? Does N equal R? No, it does not. So therefore, it is not, number 1, it's not independent, and number 2, it is not factorial. Okay? Does that make sense? Okay, so what is my N? 15. And what is my R? Alright. And then does order matter in this spot? How many ways can 10 time slots be assigned? Does order matter? It does. Order matters. Okay, so therefore is it permutation or combination? Permutation. Okay? So, and like think about that. Let's say you have to see your counselor, but you only can do it in the morning because you have like an interview in the afternoon, or you have a job that you're working to or something like. It would matter if you got slotted first or if you got slotted last, right? That would matter to you. So that's how you can kind of help indicate that. Alright, you have 5 shirts. You have 4 pairs of pants. How many different ways can you arrange your shirt and pants into an outfit? Number 1, is it independent or dependent? It's independent. So the first thing you want to do is independent or dependent. Okay? And we said it's independent. Therefore, we know we're just going to do the fun counting principle, which is going to be how many pants, how many shirts. Okay, so how many shirts do we have? 5. How many pants do we have? 4. Therefore, we have 20 ways of arranging. So and this one would be 15P10. Okay? Alright, you are taking a multiple choice test that has 10 questions. Each of the questions has 4 answers with 1 correct answer. If you select one of these 4 choices for each question and leave nothing blank, how many ways can you answer the question? So is it independent or dependent? It's what? It's independent. Okay? So therefore, is it permutation, combination, or the fun counting principle? It's going to be the fun counting principle, right? So how many questions do I have altogether? I have 10. Okay, how many answers can I have for each one? 4. So I'm going to have, where it goes, the first one is going to be 10 times 10, or 4 times 4 times 4 times 4, etc., or 4 to the 10th. Okay? Alright, telephone numbers in the United States start with 3-digit area code followed by 7 local numbers. Area codes and local numbers cannot begin with 0 or 1. How many different telephone numbers are possible? Alright, is this independent or is this dependent? Can I use the same digit for another, I have 3, and I have 3, and then I have 4. Can I use the same number? Yes or no? So here's an area code. If I choose 3 for the first digit, can I choose 3 for the second digit? The answer is yes. You can have an area code like 333. You can have a number like my number has multiple zeros in it, etc. You can have repetition. So therefore, this is independent, right? Okay. So this is that fun counting principle. Okay. It cannot begin with a 0 or a 1. So therefore, then that would limit you to your values down here. So this would be like 8 times 8. No, this would be 9 times 9. Because you can't use a 0 or 1 in the first digit. Okay.
And then
Oh, this would be 10. It'd be 10 and 10.
for the one above, why is it for the 10 hours?
Because you have 10 questions. And each question, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have 4 options for each one.
So, wait, why can't you use a 1 in the first one?
It says cannot have 0 or 1.
And then, so then what's the 4 times 4?
What's that?
What is the 4 times 4?
This just goes on and on and on.
Okay.
Yeah. Okay. So then I have 8, 10, 10, and then here I would have 8, and then I have 10, 10, and then 10, 10, 10, 10. And those would be all multiplied together. Okay? Alright, here we go. How many different teams of 10 players can be chosen from a soccer team of 11? So is this independent or dependent? Okay, so I have how many different teams of 10 players can be chosen from a soccer team of 11? Is it independent or dependent? It is dependent. Therefore, you have to ask yourself, alright, what is N? N is the full amount that you're picking from. 11. What is R? Alright, so therefore they don't equal, so it's not going to be the factorial one at all. Okay, so is it combination or permutation? Does the order matter?
No, because like it's not.
Right, it's combination. Your soccer team of 10 is your soccer team of 10, right? So then you would have 11C10. And so when you do that, you plug that into your calculator, and you should get 11. Okay? So there's 11 different ways that you can pick 10 players of a group of 11. 11 different teams you'll have. Okay? So this is a combination. Alright, so questions on, we did a little review on what independent is, the difference between when your N and your R are the same, right? That's like a factorial. When you have your N and your R different, but order matters versus order does not matter. Those are like the 3 different dependents. So when you get a question, you have to ask yourself, first, is it independent or dependent? This is number 1. Then you have to decide if it's A, B, or C. Okay? So A57 on the back is your homework. That's all this right here and all this right here. Okay? So it's 12-2.